Now we are going to talk about the design process who brings us from the architectural drawings to the construction of Marathon House. That is the second project that Nikitas from CLT House just showed us now. This content has been done in collaboration with Ergodomus. Ergodomus is a structural design office based in Italy. And Franco and Stefano are the responsible engineers who did the structural calculation of Nikita's project. So let's start. We will try to follow this path, more or less. We will try to start from the architectural drawings, pass through the structural timber calculation, the assembly drawings, the nesting we did in our production, the production of the CLT panel, the transportation to Greece, and the assembly. You have already seen the beautiful assembly from Nikitas. So we will not cover again the last point. So, as you know, if you are technicians, everything starts from a wish, everything starts from a desire. Architectural drawings. Starting from this, the structural engineer will find the right place for the structural load-bearing walls. So it means that in the plant, the structural load-bearing walls is located, and if possible, we should always keep the load-bearing wall positions repetitive per floor. So it means that you have a vertical load capacity. And of course, the load-bearing walls will be thicker out of CLT. The non-load-bearing walls can be smaller and can be done even with platform frame or other material. Of course, in the final thickness of the external wall, you always have to consider the external insulation of the house. So it means that you have to place the CLT panel centimeters offset from the external line. As I said, repetitive floors plants are the most efficient. In these pictures, you can see that the load-bearing walls are put one in top of the others in different layers. For taller buildings, we can imagine using a concrete central core for the elevator and for the stairs. It's not the case of the Marathon House, but it's a good suggestion if you have to design a tall building. Then, identified the structural load-bearing position wall, you can select the direction of the bay. In this case, you can select if you want to put the CLT panel in this direction or in this direction, depending on the size of the span. As I said, under 6 meters, you can use a CLT panel. Up over 6 meters, would be better to use CLT rib panel with glulam beams that can increase the stiffness of the floor. You can also consider using a glulam beams to shorten the span and creating a support for the two CLT panels. Coming back to Marathon House, we are talking about the 2-story residential buildings with a slope and inclined roof. All the calculation has been done based on the Greek annex of the Eurocode. It means that in the Eurocode, the structural engineer identified all the safety factor and all the structural factor. For example, here we can see the design working life. The structural material, of course, we are talking about glulam, glue-laminated timber. These numbers also applies to CLT, the same partial factors. Of course, you have to consider, when you design with wood, you have to consider the structural self-weight. As I said before, 500 kilo for cubic meter for CLT. This is the worst case when you have to calculate it as a load. Then all the other design load for each floors. Of course, you have to consider the variable load like wind, snow, seismic, as Stelios already explained. Taking into account the right load combination. I will not enter into the details, but you should follow the same path, the same step that you use for other construction material, for concrete, for steel. The limit for the flexibility, let's say, the service class. Consider that CLT can be used in service class 1 and service class 2. In this case, we consider it service class 1, and so it means the KDEF value. Let's see, for example, now, a check on one single element, on one single panel. I selected here one of the longest span, x 4.5 more or less meters, x an interior wall. And as you can see, the structural engineer calculated the thickness of 18 centimeters. How? You can also do it. You can open Calculatis and you can calculate this static calculation by yourself. You can create your static geometry. So we have a span of 4.6 meters. We added the self-weight, the load, the dead load, and the live load. This is an internal floor, so we don't have wind, we don't have snow, of course. We selected the CLT thick of yes, the CLT thickness. And the software itself can give you the results. The software itself can give you the utilization ratio of your panel. In this case, the color is green. You are utilizing the panel of 65% of its potential, so it's fantastic. It's okay. You can also have the structural report, the diagram for the shear, for the moments, the ultimate limit states, with all here you can easily understand the difference between each layer. The layer when the fiber are perpendicular and the layer with the fiber are parallel to the direction of the load. You can also have the final section in case of fire. In this case, we have an estimate of, I can't read, an estimate of 134 millimeters after fire, and we have considered here R60. So it means that after 60 minutes, you still have all this material as a load-bearing material. At the end, after all the calculation, we can say that the external walls are CLT walls, 120 millimeter. We have some glulam beams, the pink one, that can break the span. And as a floor, we have thickness of 140 and 118, as we have already said, in the first floor. In the last floor, it means in the roof, 140. So this is the typical final design for a timber structure. Here is I can show you just one example of how you can calculate the connection. In this case, we have a connection from Rotoblas, and we are talking about the connection between the CLT wall and the concrete foundation. You see here the diagrams coming from the software who make the FEM analysis of the model. We are able to extrapolate the maximum shear force that is equal to 40 kilonewton. We can divide this total shear by 2 connectors. So it means that each connectors located in these small pieces of CLT should resist for 20 kilonewton. We can take Rotoblas brochure. We can see the resistance of each connector, and we can calculate if the connector is good for us. In this case, done all the calculation, we see that it's okay, because each connector can resist for 23 kilonewton. So it means that we have to use 2 of these, and it's okay. Since this is the maximum shear load, we are safe in all the rest of the building. This is really an easy way to explain, but it's just to show you that it's really easy to do it, and you can try. I will not show you all the other calculation. I just want to say you that between the timber and the concrete, we don't have only to consider the shear, but only the tension. And Rotoblas will show you later which is the best connection in this case. The same between the interfloor connectors. Again, interfloor connectors. This is a connection between a vertical CLT wall and an horizontal CLT floor, and it's done simply with 2 screws. Having said that, Ergodomus made also the assembly drawings. It means splitting the CLT panel in a way that can be easily assembled and that can be cost efficient and time efficient to build. For example, we have, just to give you an idea, the same wall can be done splitting the panel in different smaller panels, or with one just panel and cutting the door and the window. In the first case, you need more time to assemble it. In the second case, you need less time. But in the second case, you have a lot of waste, because this material is waste. But everything depends on your project. There is not a better solution. You can choose depending on the needs of the construction site, depending on the cost, and so on. In this case, Ergodomus did these assembly drawings. So in the construction site, you can follow these drawings and assemble each element in the right place. You can see that each element has a number, a sort of labeling, so you can track the element for all the process. Next level. Remember this number, 753, because we will see it later. Assembly drawings also include connections. It means that this is a floor plan, and in the plan you can see these symbols. Each of these identificate a connectors. So, for example, the blue one is the tension connectors between the walls and the concrete. The red one X the other connectors, the green one X the last one. So in the construction site, you can easily understand where to place each connectors and to the exact position. So you can imagine how many times you can save. The same for the interfloor plans. Again, this is the typology of connectors used. Here you can see a lot of structural details. So connection between CLT panels, and the glulam. All of them are available if you, on our website, you can see a lot of these typical connections details between roof and the support for the balcony out of steel. All these details has been done by the structural engineer and should be submitted to the authority for the approval. Okay, let's move quickly to the nesting. Based on the drawings that the structural engineer gave to our customer, the customer sent to us the structural calculation, and we can do this. We can produce the element following the drawings that we got. So this is exactly the panel, how they have been produced in our factory. You can recognize the same shape of the building. I told you to remember one number, and this is to show you that the same number that you put in one panel from the architectural drawings can be found at the end of the stage in our production drawings. So if you select on the IFC model one panel, the same panel, sorry, you can see the same number. So you have full traceability of the element during all the path. And this is really important. So you can ask us to keep the same numbering, the same labeling. This is what we did. We nest every element in the big master panel. The pink line means the limit of the master panel. You have to pay all the master panel, so the best you nest them, the better. And then it's done. The production I already showed you before, what we can do. Okay. Finally, we create a loading plan. It means that we put together all the elements in the truck. We send to you, to the customer, the loading plan, and the customer can decide whenever to accept it or not. So you already know how many trucks arrive in the construction site, how the panel are putting together into the truck, and the best is that each element is located, is put on the truck exactly in the same order as you need to install it. So it means that this panel, for example, should be installed before this one. So it's completely following the order that you need in the construction site, allowing you to save a lot of time. The same, this is a vertical view. If you click on a panel, you can see the size, the weight, and you can have full control of the project. Finally, the assembly has been already shown by Nikitas. For any other information, you can contact Ergodomus. It's located in Italy. And it was good to explain how the collaboration between the producers, Stora Enso, the structural engineer, Ergodomus, the customer, Nikitas, sorry, CLT House, a collaboration between all the stakeholders is a key fact. If we collaborate from the beginning to the end, everything is perfect and you have a safe construction site.